back to my screen. So my plan was to give you a bird's eye view, an overview of how hierarchy builder is organized, how the sources are organized. Let's say, I don't know, 15 minutes, something like this, and then try to add a little feature in front of you and to start to add it. In particular, I had in mind supporting structures where the carrier is not a type, but it's rather a function that was requested the other day. So that you can see at least how I would do it. And it gives me the chance to show you a few tricks to understand why things don't work when you are developing the tool. So I'm showing you the master branch of Yarashi Builder because in the last week we spent some time organizing the code and documenting it. So it's totally different than if you have an older version. So if you want to look at the same sources I have, you should check out master. And yes, so all the code about the software is in this HB directory. Okay, and roughly there is one file per command. Okay, there is the largest one is the one for declaring structures, and then this is the one that is used to declare instances. This one is for factories and mixins, and this is for the builders, and that's mostly it. The rest is not very important. And then there is some common code that is used by these commands. Database is roughly how to access either the status of coq, I don't know, the canonical structures that are declared, the coercions, or the database of hierarchy builder, and I will spend a bit more time on it later. Log is just a proxy for the APIs of CockLP that add stuff to the environment of Coq. Like when you add a definition, you open a module, you declare a coercion and stuff. We call this API through this proxy log because it's we have a plan to be able to also produce source code for Coq, so Coq text, so that you can replace the invocation of hierarchy builder commands with the equivalent text, both for debugging, but also just in case you want to get rid of the dependency on all this on this piece of software, you can at least replace the commands with their equivalent Coq commands. And this is a component font abbreviation that is used to declare the abbreviations like name of the structure .build. Okay, they have phantom types all around the place. So this is the module that we will look into it a little, that we will use to build these abbreviations. This is an extension to the standard library of LP or CockLP. All projects do that. This is about inference. So when you want to, let's say, fill in on all the fields of a class, all the mixins, this is where we have some code to do it automatically. And this is just some utilities. So the main entry point for all of this is the structures.v file. And I want to start down here. So all the commands have a section like this in this file, and they load some of the files that are there. For example, this status prints just the status of the hierarchy. So it loads the code of one command, but also some extra utilities, okay? And it also loads a database that is called HPDB. The difference between these files that are on the hard drive and are these ones is that this is static. So every time the command runs, this does not change. Okay, while this part is dynamic in the sense that you have APIs to add stuff to this database, and this is how these commands can keep a state. You run it once, you can add to the database some stuff, and then when you run it again, you get what you added. Okay, and then there is the entry point. In this case, is called status dot print hierarchy. Okay, we try to put most of the code inside a namespace. So a namespace would be this fragment of the name. Okay, given that this code is inside the status file, we try to put it into the status namespace so that you know where things come from. We didn't finish completely to do that, but most of the time it is the case. And so I think that the most important part to look is this database for now. Okay. And sorry, all the commands are like that. There is some documentation, the list of files that they load, and the database. Okay. So let's look at the database. A database typically declares some predicates, and then the API you have will add some clauses for these predicates. Okay. In this case, we also define some types. Okay. These will be quite recurrent. So grf is the name in CockLP of global objects in Coq. So an inductive type constructor, a definition. Okay. But we have type aliases here, so that when we give the type of our predicates, of our functions, we can be a bit more precise. Okay, so we have one for mixins, for classes, factories, and structures. Okay, and then there is this complicated data type that I think it's easier to explain with an example rather than looking at the type definition. That is called list with params. Okay, this is the one I'm talking about, and that we use to describe how classes are made. Okay, so here I took the example of the class for the left module. Okay, the left module has one parameter r, and so the class has to group all the mixins that are in the structures plus the information that says how parameters are passed to these mixins. For example, a left module is a Z module that doesn't have any parameter, okay? But then it also uses the mixin just above that has one parameter that is a ring, okay? So in some sense, we have to record the fact that this parameter R is passed in this form, in this case, exactly as it is, to this mixin, okay? So the class predicate has three arguments. The name of the class, okay, the name of the class is an inductive type. It's called like this, left module dot axioms. Then the name of the structure in which the class is used, that given our convention is called lmodule dot type. And then one of these lists with parameters of mixins, okay? This is like the list data type, but a list of mixins, but also with parameters on top. Okay, so here we have one parameter, and so we have this constructor of this fancy data type that's called cons because it reminds us of the cons, but it's the cons of the parameter. So it's saying uh, we have a non-empty list of parameters. It's called R. Okay, the user gave R as the name of the parameter. The type of the parameter is a Coq term, in this case, a ring.type. Okay, and then this is a binder of LP, of lambda prolog. Okay, and it means that we know where this P is actually used in what follows, and it is used down here. We will see in a minute. Then the nil node of this special list constructor is not empty, but carries the last thing, the key of the structure. that we called M here, for example, that is a type, okay? And that we also bind it so that we know how it is used, okay? This is, if you look at the list of mixins that is there, it's a list of triples actually. There is the name of the mixin. For example, there is one for modules, and then there is the new one that we added here um, for sorry for for L modules. Okay, then there is the list of parameters that we are passing to these mixins. In the first case, it's empty. There are no parameters here. Well, this is the name actually of the structure that unfolds to all the mixins that are in there, and none of them have parameters. So maybe some are here and one is there. It has no parameter. And then, of course, we also carry here for, because it's easier to do this way, to also to have a pointer to the type, okay, the key of the structure, so that if we want to instantiate, for example, these things passing a specific value for the parameter or a specific value for the type, we can recover them in the list, what we passed for the parameters and what we passed for the type. Okay. Feel free to interrupt me, ask questions, or correct me if I'm saying some silly things, Cyril.
There was a question by Asia.
I'm not reading the chat, so please.
Okay, so I answered it in the chat, but
Okay, I can ask my question.
yeah, yes.
Enrico, I did not get immediately your line 68, where yeah, this one in the comments. So it says M module of R is M of the module M, and the module is blah 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 blah. Okay. So my
Right.
question was about the beginning. So I understand that off is is the usual idiom for something you don't want to name and so on. But I had trouble reading the types of everyone and who's implicit. It was a bit hard to read. So
Okay.
Cyril answered that it's like a 3-field record where M is a guy of type. I mean,
Indeed.
yeah. So
I can
maybe you
explain
can
it a little
explain.
better.
Yeah.
We also need to look at it later, so it will just jump to it right now. This is the concrete syntax of hierarchy builder, and this is a coq term, okay? And we have a special notation for this term. You have to see it as a sigma type, actually, okay?
Sigma
Where,
tuple?
yes, it's a
Yeah.
dependent tuple. And if we go up here, it's really there. So when you write,
Okay.
so it's a sig t, okay, of the A that you write here, plus the iterated pair of all the things you put in there.
Okay. And you also have the implicit type annotation on A. So the first guy is always of type, right?
Yes. And given that the plan was later to extend the system to allow something different, these notations will have to be adjusted. Okay, because here we are fixing the type, but
yeah. So my question was really that in this notation, I could not understand how all the pieces of information, typing and so on, was inferred. But the answer is that it's hardwired in the notation that M has column type.
yes, and actually, in coq, without hierarchy builder, without if you have a parameter that has nothing, I think it expects it. I mean, sometimes it sticks type to it if you say nothing. If it knows it is a type.
Yes.
Sorry.
Yeah, most of the time, if you don't say anything and it's typeable as type, then it will coq will affect it the type
Instead of prop or as prop. Okay. And we do the same inside the hierarchy builder. So if there is something that looks like a type, we don't know the sort exactly, we stick to it type. We will see it because we will have to change it as well.
Okay, thanks.
So okay, so that's the I wanted to show the data structure because first is the most complicated one, and is also the ones that defines the hierarchy we have. Each class is represented like that. It uses higher order abstract syntax to explain. This is just to remind you, this is the notation for the lambda abstraction. So here we are binding this p here. So it's really, this subterm here is a function. We can pass a parameter to it and it will put it there for us, okay? And also we will have to touch a little piece of code that uses the data structure later on. So it's nice that you see it. And then I think the next, so there is more stuff in the database, not just the classes that were defined so far. I won't spend too much time on it, but for as you can expect, there is all the builders that were defined, how to build a structure out of a factory, for example. Okay, and in this case, you have a way, a global coq term to build a mixin out of a factory, for example. This, well, I will skip that. There is some caches of known fact. For example, we are able to recognize immediately if something is a structure that was declared with hierarchy builder or not, and stuff like that. And let's say if there is something interesting in there to show. Yeah, for example, the first time a mixin is used in a structure, okay, we want to export the operation. So you want, and this is how we remember things. Okay, we remember if an operation was already exported by adding one of these clauses to the database. Okay, we said that the operation comes from this mixin and it was exported. So
Enrico?
sure.
Enrico? I don't understand this line. So what is the OO? Why I don't understand. Can you?
So it means that in the database we will have stuff that is like exported of three things. Okay, the first guy will be of type mixin name, so it is going to be the type of a
Exported
mixin.
up.
Yeah, right. Sorry.
Yeah. Okay.
The type of the mixin. This is the name of a global constant. So it cannot be an inductive type. It cannot be an inductive type constructor. It must be a constant, and this as well. And I don't remember exactly what they are. So clearly
Okay.
to do document fields. The O part, okay, you could write this just, I don't mind repeating some, explaining some stuff about LP while I'm at it. This, the line above really means this.
Okay.
So it is a predicate of these
Okay.
three arguments.
Okay.
And they are all, you can pass one or the other. It's really a relation. You
Yeah.
don't
Okay.
have to see it as a function that takes, let's say, this is an input and these are outputs. Okay, it's all, everything is declared as output, so it's really a relation.
Okay. Thanks. That was just enlightening. The last thing you wrote. Thanks.
So the O word is to give mode information, input or
Exactly.
output.
So in the database, everything is a relation, but in the code we write, 99.9% of the code we write is going to be a function. So it will have some arguments flagged as inputs and some as outputs. And okay, so the next thing I wanted to show you was, I think it was this one. Yes. So I will just look at the code of this of this command. As you can see, there are two concrete syntaxes for declaring instances. Okay, one that is the most widely used. It is the one where you pass to this command a definition, okay, where you build the body of the definition is a factory instance out of which many mixins can be generated, and then the system figures out which structures can be, which classes can be can be filled with these mixins, and then it declares all these instances as canonical. And there is a more low level one in which you pass to it the key and the factory instance that you have built one way or another, okay? And this is just to show you the two entry points. In this case, the argument is they are in the inverse order. So the first case is when the argument is a definition, is a declaration of a constant that has a name. In this case, it has somebody. And when the terms have not been type checked yet or elaborated yet, we call them skeletons. Okay, so it's the skeleton of a body and the skeleton of a type with some parameters. WP stands for with parameters all over the place in the code. And then we call the main entry point that is in the instance file, and it's called declare const. And there is another one where it's called declaring an existing thing. And in this case, it takes two arguments that will be processed by the command itself. And this is a general combinator that we use in all, you see, in all commands, that is there to understand attributes. Attributes are these things in Coq. It's a rather recent thing where you can write some flags for the command. Most of our commands support, for example, verbose. Okay, and this combinator sets things up so that later on the command, the code of the command knows that you passed verbose. Okay, and you can make decisions out of this fact. So let's look at the code of instance. Okay, let's start with the low level one where we were passing two arguments. Remember, maybe I can put it here. I don't know if it is too small. Let's see. Yes, here we were passing these two guys, T0 and F0, as they are with no nothing, and their type is argument. Okay, that can be many things, and we have some utility functions that try to type check the first guy as a type. Here it was the key, and the second one we just want it to be a term that then we will interpret as a factory and do stuff with it. Okay, then we call some code that is in this private module. Okay, most of these files are organized in this way. There is the public part. The file is called instance. The public part is in a namespace called instance, and later on there is some private code that is in a sub namespace called private. Okay, so from the outside, everything that is in this section of the file is called instance dot declare existing, as we do here. And actually, you can even access the code that is in private. It would be called instance dot private dot add mixin. Okay, for example. Okay, but we try to keep the two things separate so that you know that this is the public part of the file, and the rest is internal stuff that other modules don't use. Okay, so it's not enforced by the compiler, but it is a convention. So most of the commands are really organized like that. So there is some code processing the input, then there is the main the meat of the command, and then what we do is to put something in the database because it's nice to know it later on that something happened. Okay, and in this case the command, the main code of the command generates some clauses that we accumulate on our database. Okay, this is very recurrent, so this is what I wanted to, why I wanted to show you this little command. And if you can see what happens in the more elaborate command, okay, well, we have the body of the definition, and what we do, in a way or another, we have to elaborate it. So there are some APIs to type check the type and type check the body. Okay, and most of the time we try to put assertions. Okay, so if it doesn't work, you get an error message followed by the typing error given by Coq. Okay, and these messages are important because when you get one and you can find in the source code where it is emitted. So they all different typically. Okay. And in this case, you see that the high level command kind of elaborates to the low level one. Okay. For example, it may start a section if needed. Okay. It creates a, let's say, a random name for the section, and then it begins the section, and then it postulates what we call the arity. The arity would be this guy here. So sorry, the parameters of the factory, and indeed it looks like postulating these variables. Okay. Then we try to identify the factory and so on and so forth. Okay, it's not really important to see each and every comma, each and every line now, but it follows the same pattern. So there is some processing of the arguments, then the main code, and then finally we store in the database some knowledge. Okay, and for example here we spread the code with lines like this that says if you passed the verbose attribute to the command, then we print something while we execute it. Okay, and this is kind of the first friend when you want to understand why your code broke. You put it in verbose mode and you see where it stops. Okay, questions? Okay, so my plan was to now start to implement um, this feature I was talking about, that carriers are functions, can be functions. And the way I would do it is to first start to write a spec, a sort of a test file for what I want to obtain, and add it to the test suite. So let me add it to the test suite as well. Otherwise I will forget. And okay, so what do we want to do now? We would like to define structures where this guy is not a type anymore. Okay. And in this case, it will be it's given by the mixin here. There is a type parameter t, and then f is a function. And here I just wrote the associativity, and then another mixin about the function that says that it has a neutral element, and another structure that says that we finally have a monoid. So we have neutrals and associativity for this function symbol here. Okay. Then okay, we can continue with some tests, but I think this is already would be already great if we can run that. Okay, so if we run make tests from class.vo, it breaks. Okay, why? Well, it breaks at line 6, so the mixin already passed. Okay, I can also do it interactively if I didn't break my environment, which I did. So sorry, I did something wrong. I need to restart Visual Studio, sorry.
May I ask a question meanwhile?
Sure.
So my question is about what hp.mixin, the hp.mixin command does. As far as I understand, it's just defines a record, right? I mean, and does some storing of metadata in databases. That's why no error occurred at this stage. Is it true?
Yes.
There is no
although
specific condition on the well-formedness of mixins.
So there should be. So I am a little bit surprised that it works, because I thought it would expect the element f to be a type. So
Well, it does
already, so it means we didn't over specify it at least, but there is a little bit of check. For example, after the key f in this case, there should be only mixins and factories as parameters. So there is some restrictions on what a mixin can do.
What is the key?
So in this case, it's f. It's the.
But how do we know that f is the key?
That's inferred automatically by HB, but it should be in some cases.
In this case, how? I mean, if I have several parameters.
So it is the, let's say, it is the last one. Not always, because sometimes after.
No, but my question is about what Cyril says. Cyril said, after f the key, there should be only mixins. But my understanding is that it's the other way around. It's the last parameter before there is only mixin.
Exactly.
Key. Yeah,
exactly.
So it's not a requirement. It's just that it will take as the key the last guy before the possibly empty lists of.
Yes, but if there is an alternance, if you by mistake you put an element which is not a mixin in the middle of mixins, then the system will be lost. There is. I was just saying that there is.
Why it will take the last parameter before the.
Because it asserts. Yeah.
Sorry, go ahead.
Because it asserts that once you start with a mixin, then it can only be mixins. So there is. It was an answer to your question. Yes. So it's an answer to your question. It's just a record. We don't perform any check. Yes, we do. There is some indexing which is made at this stage, which already requires.
But then I agree. I don't understand why. I mean, I thought you were only allowing type key.
Me too.
So
the only check is that. Okay. No, I'm not sure I understand, but anyway.
So what I'm doing now is to. I don't think maybe there is something to fix, okay? But at least the command works. Then maybe it declared some abbreviation that is not perfect. Something is broken, okay? But at least it runs. And so we can start to test it, okay? Unfortunately, there is not much you can do with a mixin if you don't declare a structure with it. So you cannot really test. We can print a module, but I don't know if we can already see something is wrong. So, for example, the last line that was printed doesn't seem too wrong to me. For example, because
except for the
choice of the name. The type annotation seems okay. So the type is a convention in the code, and we call the type the key, okay? Because it was always a type, so we should probably rename this the key, but at least the type on it is okay. Do you see?
I think the best name would be to keep the username.
Yeah.
The type is the meta variable in LP, but it doesn't. I mean, sometimes in the code we didn't have the name at hand, so we wrote the type in a string explicitly, but we should really catch the name and put it there.
Okay, so anyway, there is a lot of work to do, and let's see what happens when you run the next line. You get the error message that is printed down here. Okay, and as I told you before, this is important. And if I look in the source code for this, we can find a place where things start to go wrong. Okay, and this is inside the structure file declare. And if we go to the structures.v file, where is it here? No. Okay, we say that the entry point is really that. So we expect the definition, okay, and then we pass the body as it is to this piece of code, okay. So this piece of code receives B, that is a term, raw. Then it runs some stuff that we don't understand on it, and then it tries to type check it, okay, and we get the error message. So it's likely that this B1 is wrong, okay. So yes, I forgot to tell you another thing that is easier to see here. As I was saying at the very beginning, 99% of the code we write is a function. There is no backtracking going on. We're not computing a relation as you can do with logic programming languages. So we use this little combinator here from the standard library that takes a list of things to do. Okay. Internally, these things can do backtracking, but after they finished, we pick the first solution they gave. Okay. So this is really do this, never look back, do that, never look back, so on and so forth. Okay. One advantage of using a standard combinator is that it gives us the chance to add some debugging information in it. So now we know that this line goes bad. We could sneak in a spy, and now the combinator will run the commands, but also tell us what's the input and what's the output, okay, of each of them. And of course, we will see that the value of B1 will be something fishy, will be something that doesn't type check. Let's see if it is true.
But then in order to introduce the spy, you need to like edit the sources and recompile everything, right?
Yeah, that is true. There is another debugging facility that doesn't require you to edit the source. Oh, come on. Salut Maxime. Oui, mais je suis sur un rendez-vous là. Après-midi. Sinon, tu regardes ma comp dev et tu te connectes aussi. Bon. Ciao. À toutes. OK. Bon. So, okay. There was this purge thing that we don't care about, but it's just to show you that there is enter, and then you see what B holds, okay? And then B1 is this guy here. And once the command runs, you get both the input, what you gave as an input, and what you gave as an output, okay? And then we run the elaboration on it, and it breaks, okay? And if we look a little at this term, we could print it to get it in a nicer way, but it's a function that takes a t and its type is unknown. And then there is the application of this sig_t constructor. And then there is another function that imposes that f is actually a sort, and a sort type, not a sort like prop. Okay, and so well, we did nothing before we did nothing to this input. It's really what the user wrote, and this points to the previous question of Asia, that is that when we write this, we are using a notation that is defined here, and this notation fixes the type. So the first thing I have to do is to remove that. Okay, and I don't think I can remove this pi. Okay, and see where it goes. Ooh. Now it is still failing at this line, but this time the error is something that comes from Coq, that complains that some target class was sort class instead of fun class. Okay. Yeah, you need to have used the Coq a little to know that this comes from the fact that you declare a coercion. Okay. It's the same error message you would get if you declare a coercion with the wrong target. So, well, the hope is that if I look for coercion in this HB structure, maybe another thing I could do to make it easier to understand is to put verbose. Maybe this was the right thing to do from the very beginning. And so it prints what it does. It starts a module, it declares the record blah blah, so the class, and then it type checks it, then declares the record that packs the carrier with a class, some abbreviations, and then it starts to do stuff, and then declare sort coercion, and then boom. Okay, so let's see, where is this declare sort coercion? It is in a function that is called declare sort coercion. Let me go, and indeed, okay. We just printed, this is in, okay, you do not recognize it, but this is still in the main code of declare structure, okay? And after some stuff, what we do, we start a module that is called export, and this is what is printed here, okay? And then we call some private piece of code that declares the sort projection as a coercion, okay? And we call it twice. This is a feature that recently added by Cyril for MathComp that lets you alias the coercion. So you declare two of them with two different names so that you can use one or the other to index canonical structures. But anyway, what goes wrong here is that the sort projection of the record that was defined is a function, is not a it's not a type, so it's not the sort class, but it's rather fun class. And if we look at the class that was declared, this is the data structure that I showed you at the very beginning of the demo. There is a parameter t which happens to be a type, and this is the name of the level, okay? And then the guy f, the key, it's a product, so it's a function from t to t to t, okay? And then there is just one mixin with one parameter about f, okay? This is the parameter, and this is f. So, and the code that we just saw, it prints a thing, and then it passes sort class to the API to declare coercions. Okay, the API takes a tuple, a record. This is the constructor of this tuple. It wants to get the constant that is declared as a coercion, and the source. It goes from the structure 2, and then this is depends on this is the what okay, as this would be code, okay. One in Cog would write something like this, okay, and clearly writing short class here is wrong. Is wrong in general, okay. It's okay for so what we could do is to take in input something more. This is the TGT class, or maybe core class, and do something like this, okay. The sort coercion is not necessarily to sort class, okay. Yeah, I will do this typo a billion of times. Class, and then we try to pass to this piece of code the right class, so either sort class or fun class or something else. And the idea is to write a new piece of code. Let's call it like this. That takes this guy. Okay, this guy is called is this is the list of mixins with parameters. Okay, it's always the we call it like that all the time, and it is also what is printed. Well, it's printed from another piece of code, but this is what we will inspect, and this is what we will infer. So we will pass to this guy, and we will pass it to this guy. So let's go inside the private part. We take a list with parameters of mixin name, of mixins, and we output a class. Okay. So we have two cases, vparams cons and vparams nil. Vparams cons, we get an ID, the type, and the rest. And then we have another case for vparam nil, or many cases actually. Let's start from the second one, the nil. Okay. We don't really care about the name f here. What we care is what we find here. So if here we find a type, then what we are looking for is sort class. If we find a function like here, then it's fun class. And if we find something else, sorry. Well, I'm not going to do it today. Okay, but we give an error. Okay. And for the cons case, well, we don't really care. We want to just to look at what's below this binder. Okay. And the way you do it in Lambda Prolog is to postulate a fresh symbol for this with pi. And then you can apply f to this symbol to get to the body. And on the body, we call the same thing. Okay, we do a recursion over the next element in the list and postulating a symbol. There is, given that it happens so often, there is a macro where you pass everything. And this is the most polite way of doing things. So we want to move under a parameter, we postulate the parameter, and then in the code that follows, we can use x as a fresh name for the parameter. So okay, let's see how it explodes. So it still breaks in this line. But if we look at all the output, the sort coercion was declared. Okay. Then there is stuff about unification ins, coercions, mixins, blah, 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 blah. And then there is declaring of abbreviation, and it blows up. Okay. Let me see what it is this declare of, no, declaring of abbreviation. Okay. Well, actually, between this print and the print we don't see, there are two steps. So, which is the one that breaks? And let's see the error message. There is still something that is expected to have type, but as type, this is harder to read because we are in the middle of the module. So I was called magma.type is printed without the magma. So this is the type of the structure. Okay, so there's something very fishy in here. Let me see which is the easiest way to figure out what's going on. Let's do this. This is another way to get some debug information from one line instead of all the lines in the file. Okay, you spy the line so that you see what gets in and what gets out. And here you see whether we pass the projection to the class, a list with parameter that has been, how can I say, trashed. We take the list of mixins with parameters and we put nil as the list of mixins. So we get some parameters with no mixins in the end. So I don't know exactly why we do that, but this is what we do. And then we pass the name of the structure, and then this API give us something. So let me see what it give us, and if it looks fishy. Yeah. So we call this mk infer key, and in output it gives us this thing. And I need to detail a little what it is. But if we see again, there is a function over t that is a type, and then a function over f, which is this. And then what's wrong? This is the thing. Okay. So, well, let's go to the file. And let's print what this is, because maybe we don't remember exactly. To do abbreviations, we use these constants that are part of SS reflect. Let's see if this reminds us. Okay, so in order to trigger some inference, we use these phantom arguments. Okay, here the P, where was the, okay, this is the little font. Okay, so the little font, the first argument is expected to be a type. Okay, while there is another thing in SAS reflect, that is the one in which the argument does not need to be a type. It can be of type T for any T. Okay, so when we build, so far, in order to build our abbreviations that infer stuff with phantom types, we could use this because we always had types. Now that we have functions, we need to use something that is more general because we want to put here A, arrow B, arrow C, or something like this, okay, instead of type. And this is where the type checking error comes from, okay. There is a phantom argument, FPH, and its type is the application of the phant, the one that is hardwired to type, to C1, but C1 is not a type, is not type, is going to be a function. So I think I need to open the thing about font abbreviations, but first, yeah, maybe I should have opened it before. Let me see. Let's look at this code, okay. mkinf_k, it takes some term that I don't know what it is, then this list of parameters, and then another term that is the structure, I think, it's called st, and it has to build a font term, okay. Font term comes from this file, and this is part of the API. It's a data type we shouldn't use explicitly, but build it using this API that okay, there are two APIs, one to build a font term and one to use the font term to declare an abbreviation, okay. And an abbreviation is made of two things, a constant with the right type and the right arguments, and a notation that passes to this constant some identity functions to trigger the phantom inference, okay. This is a bit technical and it's explained in this paper we wrote a long ago. But anyway, the API works in two steps. So first you have to build this phantom term, and then there is this to declare the constant and the abbreviation. And indeed, the error message we were getting, till typed in add abbreviation till typed, is come from here. Okay. And we can see here that the phantom term that we build with the API in this file is actually a pair of things, okay? One is a term that in this case doesn't type check. And the other one is a specification of what the arguments are. You see here, for some of the arguments of the term, for some of the arguments, you need to pass the argument as it is. For some, you need to pass an implicit. For some, you need to pass an identity function and stuff like that, okay? So we have to look at the APIs we use to build this term because it is misused, because it puts in there a term that is not well typed, okay? And the way we call the API is we use the low-level API in particular there, and it has APIs to add a real argument or a unify argument or an implicit argument or an inferred type argument, okay? And this is where the problem is, okay? And here we see the HP font that we saw before. Let's try to look at what this API does, okay? It produces a phantom term, and it produces step by step, so adding argument. And in this specific case, we remember that the argument in question is something to infer stuff, so it uses some phantom, and at the same time it builds the term, sorry, by making this abstraction and passing some th that, I mean, it takes two things actually. Sorry, this is sorry. The type of the lambda abstraction, okay, phn, is the application of this font to some t that whatever it is, we don't care, okay. So this clearly is not what we want. Here we have to put phantom, okay, and we use this API here. I saw it just before. So this little private API here builds something that maybe I don't remember what it is, but it goes by recursion over this data type again that we saw before, okay? And when there is a parameter, okay, Well, it does the recursive call, but then it wraps around it an implicit argument. That doesn't seem to be the problem. While when we reach the key, the type, we try to infer it calling this we want to infer it calling the API we just saw. Okay. So the idea is that I'm trying to I will make it a bit more general here, passing the class. And in order to pass the class to this API, I have to pass it to this function. Okay, so let me put it everywhere here. Here.
Enrico,
Yes.
can interrupt you here?
Oh, sure.
I mean, may I suggest another way to fix this,
Mm-hmm.
or could we do it in a? I mean, what do you prefer? Do you have in mind the rest of the thing? Or
Yes, because we already know the class, so we can pass it
okay.
down.
Because the a better fix, in my opinion, would be instead of passing the class would be to pass a shape to make the coercion. So in fact, we will call ultimately funinfer type, which will put a font. And if we change the class, we call funinfer. Well, it's misnamed now. It's not type anymore. And we should put a phantom. But actually, the phantom could work in any case. And all we have to do is provide to phantom the right type. So if we provide type to phantom, then it's equivalent to font, and otherwise we provide what we expect, like a function, and it will do the job.
So I
So
think I understand what you say, but I think it's I will point it out the improvement when I touch that code. So
okay,
let me continue this way, then we
sure.
can go back and clean it up. So mkinfer key is called here, and here I think we already have inferred this coe class. Okay, so I can just pass it. Let me remove this pi that I don't care anymore. So now mkinfer key receives also the class, and we pass it around, but more importantly we pass to fun infer type. Okay, and okay, so there is another call here, so we will have a type error, I guess, at some point, but let's go here. So now here we take also the class of the coercion, and let me do 2 cases plus an error 1, 1, 2, 3, 4. To do. So the case in which we are doing something about a type, we keep the code as it is. And the case in which we talk about functions, we try to change the code. So let me do this. Maybe it's a bit more readable. So here we are building a term, but we are also scheduling for later the fact that we will need to pass some argument for that abstraction here. So here we would like to use the bigger phantom, and we would like to put here something that looks like a function space. Okay. But we also have to remember later on that the constructor of this guy is not is different from the constructor of this guy. Okay, and this is where the solution of Cyril to always use phantom could be a bit nicer than having two separate cases here. But I think it's
Actually,
if we remember that in this case we have to pass big phant, and that in this case we have to pass big phantom. Okay, and now let me see what is this infer type. Okay, because we didn't see it before. This is these are the arguments for the notation, okay? And infer type was just taking a name to, to to be nice, okay? But actually here we put it, we added an argument, also the class, okay? And the code that uses infer type is here. So when we in the to build the notation here, it will pass big font of the thing, okay? So let me do the quick and dirty solution once more. 1, 2, 3, 4, 5. Okay. And so if we had to infer a sort class, we do this. If we have to infer a fun class, we pass phantom, and again, I think probably this is a term anyway. This and the other one are terms that are going to be elaborated. Okay, so we can put holes. Okay, and what Cyril was suggesting is that here I could say phantom and write type. Okay, and avoid having to use one or the other. We could just use the more general one all the times, which makes sense, but maybe it's not the quickest fix. So let's do it like
Are you
this.
sure you need to put the type explicitly with the constructor? I think only the argument is
Okay.
required.
I don't think. I don't know. Well, this seems safe
I
as well.
can't remember.
And this is something is a notation. Here we enter the coq syntax, okay? And this is a notation to access what is called the cocklib. Typically, you don't have it because it's accessible only from the ML side of coq. But it's a way to give names to known constant, okay, to alias known constant. And if we go here, you see that we register little font and big font as with shorter names that are used inside our code. Okay, so that if this constant is moved to another file, our code doesn't break. This is the, and here we, in order to use them, we want to register the other two as well. Okay, so let me see what I forgot. So, well, it says that something has type name but is used with type class, and this something spilled is this notation with the curly braces. It's not very important what it is, but we added an argument to fun infer type, and we forgot to put something in here. Okay. Well, let's put sort class and see how it goes. What happens now? Oh, we shouldn't. I think we shouldn't pass sort class in here. Right? Okay, let's see.
Yes,
Declaring
I
clone
think
abbreviation.
it's the right default case. I mean, it should preserve the former behavior, right?
Yeah, let me see what I broke. Declaring clone abbreviation. But it's one of my to-dos. Okay, sorry. Which one? This seems to be wrong. It's not this one. I must have done something silly somewhere. To do two. Seems a bit weird, right? All right. Sorry. I did something super
Yes,
stupid.
you did something silly. I didn't see it either.
So there is another constructor for this data type. That is the case in which the coercion goes to a name. Okay. But there are other cases of this function that shouldn't be killed by the fact that I didn't implement this one. Let me see if I did the same mistake above in the file. No. I think this is fine. Oh, yes. When a variable is not used, you get a warning. Most of the times is because you screwed up something. In this case, it was not a problem, but... Okay, now what happens? Oh. We made some progress, so let me restart Coq. And remove this. So we can now declare the first structure, the second mixin, and we get an error. And, well, whatever this is, we'll look for him. So we are again in the declaration of the structure, and this time there is some term that is badly typed. Okay. Oops. And it is not even printed what it is. Okay. So maybe we can print it to see the shape that it has, but we can also look at the code that builds it. So this is yet another instance of the data type we discussed, the list of some mixins, in this case the F mixins that I don't know what they are, with parameters. Okay, and then this is a generic combinator that takes this list and will build a lambda abstraction for each parameter. It will not build a lambda abstraction for the key, and then it will call this function to produce the body. Okay, here we are, I guess we want to produce the body of some coercions to the structure, I guess, S. And if I look at this code, okay, it takes a lot of things: the structure where we come from, the structure we go to, some factory name that I don't know if it is important or not. Anyway, some other coercions, and then it produces a term. Okay, and the term produced is down here. Okay, and it is a lambda abstraction over something that looks like the structure S, and then we do a let t equal the application of the sort projection to S, and then we pack together this guy, the carrier, with the we project out the class of the structure, and then we put another coercion in there. So I don't know exactly what it does, but the sort projection of a structure is not necessarily a type. This is what we are changing this, so this is probably going to be something that doesn't work anyway. So let's remove this type. Looks interesting because now we reach this point. So, okay. Let me reset coq. So now it seems we can define the two structures. And if we print the identity, let me clear the output. If we print the identity, it says that, well, it has a two implicit parameters. One is the type for the function, and then there is a monoid of functions over the type, and then it's an inhabitant of the type, so it makes sense. And what do I do here in my test? I try to build instances of the first mixin, which is the associativity thing. I pass the parameter that is not the operator and the theorem that is part of the library that is about associativity. Then I had to do this because in the standard library of coq, you have this the other way around. So I prove it, and then I say that plus with 0 and these two proofs also has a neutral element. And then this is one of the abbreviations we provide, we synthesize, the one we fixed actually. And if I run it, there is some phantom ugliness, but then there is the term that says that addition is a monoid. And if I print it, no, what did I do? Coq print, yes. I don't know why it doesn't work today. Anyway, print is called add is a monoid. Okay, and this was inferred. We just gave plus, and it inferred the structure instance. So there is the sort projection is plus. Okay, it plus I think is probably a notation, an abbreviation for this guy, and then the class as the two mixins we expect. Okay, and then they were built and given names. This is not really important, but we have an instance of monoid type, and the carrier is the function we wanted. Okay, so it's kind of work. And if I use the axiom that comes from here, maybe I can do an about of this. Okay, it really wants the operation to be in the carrier of the monoid, right? So it seems the fact that I can rewrite on the concrete instance seems to indicate that inference is fine. So I want to make my test a bit more precise. Now it seems I can define structures and mix in over functions as well. And here I try to define a factory. It's silly, I have no idea if it makes any sense, but it's a factory that takes everything at once, but instead of taking the identity to the right, it takes the commutativity. Okay, whatever, an instance of the commutativity. I mean, it's just to test if it works. So this one kind of is accepted. It's like the mixin thing. We check it as a certain shape, but then we don't enforce too much stuff. But I think that here we get an error, right? So The error it's there. It says ELP, the last context item before the factory must be a type variable. So, well, this is clearly not true anymore.
Enrico,
Yes.
can you recall what line 36 is supposed to do?
Okay. Yes. Right. So, okay, this is a command, and this is what we pass. We are passing a context in which we have two parameters and a factory instance. Okay. The idea is that
Which is anonymous.
yes, we can give it a name. Okay. We can. Okay. I was using type inference, but this is what you are saying. We want to postulate a context in which we have tf and an instance of this factory. And what it will do behind the scenes is that it will postulate roughly these three section variables, but it will also postulate all the mixins that can be generated out of this factory and all its
No, that's
requirements.
this. No, not the mixins that can be generated
Yeah,
out
yeah,
of
sorry.
factory because we don't have them. So only
Yeah,
the mixins that this factory requires, which
yeah.
is none in this
In
case.
this case, there is no off here, so it won't postulate the dependencies. And yes, I was saying the other way around. What we will do in this section is to explain HB how to build mixins out of the factory. Okay. So yes, and the idea, what you do is that you inside the section you give instances of mixins you already know
Sorry,
or factories you already know.
I still don't get exactly. What?
It
Yes,
opens this basically it opens a section with a lot of context that is generated, so that f has is sufficiently annotated. In this case, it's
But in this case, what is generated exactly?
in this case nothing is generated, and it provides you a section with exactly the context that is written.
Okay, so that was my question. So in this specific example, the only effect of line 36 is to create a section whose name we don't know, it's irrelevant,
yes,
and then context, it's akin to context tf small f.
yeah. There
Yes.
is one extra thing that happens is that it will also give you access to the operations of the factory with the short name. So
Okay.
now it doesn't. We will fix it. But here, if I do check ID, okay, sorry,
Okay.
it won't be the ID. This where was it? This one, the one that comes from the operation of the
Okay.
monoid, the element of the monoid, but it will be the one of the factory.
Okay.
Okay. And indeed here I will build an instance of the of that mixin using this that comes from F. This comes from F. I don't have ID R because F has something else in place. And so for I will provide a proof for it. You see what it also does?
So ID is the ID which is at line 37 is in fact the ID which is at line 31
Exactly.
applied to small f.
Exactly. So it will be is the it projects from F instead of expecting a monoid over something.
Wow. Isn't that, I mean, and what if I postulate two instances of modes?
You can't. The syntax
can't.
of builders allow you to put only one factory because it's the builders of a specific factory. So there is no.
Next question is what if I postulate two factories which share a same projection name?
So here you cannot put two of them. Okay.
Yeah, I
You
understand.
can access the one that is shadowed. You can access it by writing this. So it will also create a little module super with
Okay.
all the shadowed constants.
Okay, that was my question actually.
Okay.
Okay.
So yeah. Okay, so it fails with this error message. I think we are very close to have the thing working. So here, okay, we jump to this piece of code that says postulate factories, and essentially tries to elaborate some stuff. And then it says if it's still a variable, let's say it's a fresh type. Okay, let's pick a type and type check it. Okay. But otherwise, if it's not unknown, if it's not an either, if the user wrote something, here the code really tries hard to unify it with type. We were very strict in that. I don't think it was particularly sensible to do. So what I will do, I will just say nothing here. True. Okay. Oops. So if the type is not given, we can assign it to type as a default, as Coq does. Otherwise, well, we keep what the user wanted. Okay, it comes from this function here that asserts that this guy is also a type. Okay, so
Shouldn't we try to elaborate using as many context items as we can? I think that's the ultimate behavior. So assigning type to a variable with no body, no, sorry, with no type, sorry, um, is the default only when inference failed to infer anything else. Right?
yes.
So here we should
No, it's
elaborate.
not failed. I think I think I fixed that. So we run type inference. What is it? We run if you say this f. This is what it was there in the first place. I think it infers stuff. It's just that it uses.
Mm,
It's really unconstrained. When it is unconstrained, like this
oh yes,
guy, well, it will pick. Actually, in this case, it will be constrained because here, I think it inferred the type here, and so it will be constrained there. Anyway,
yes, okay.
that's it. So I removed the error because, okay, exactly what we want to relax. Okay, and we were lucky. So now the context is there. This is easy to do because we already have everything we want here, a sock. And maybe in the proof you will see the context. What's the warning? Okay, the projection to the class is still there, and we didn't make it non-canonical. So now you see a bit of the implementation. Okay, so you see that it postulated T and F. It postulated, well, it's fun taxon because sometimes here there are no parameters, no parameters, but it may help to infer stuff. And then you are in this context, and IDL. Let me see if I can see something here. Come on. Why you don't want to print IDL?
You should restart VS Code.
Okay. So you see that, yeah, I mean, I wanted to print it inside for a reason. You see that it postulated an inhabitant of the factory of MOT, okay, and IDL is the projection out of this guy. So it's really taking the one from the factory instance. Well, if I say super IDL, what is this?
It's the top level module. The file you're in is called fun class, and
Yeah.
since we define IDL in the top level, it's just an alias for the class.idl. So a little bit earlier, so maybe Asia's question was not completely precise about what happens if you have two factories. So the putting symbols in the context happens only when we are in a HB builders context. The ID, IDL, and etc. from the factory MOT are all located inside a module called MOT. They are not exported. That's one of the things that HB mixin and HB factories do. They put the names of the fields inside a submodule so that they don't pollute the global namespace.
Yeah, so declaring a factory or a mixin has the only visible effect of creating a module called as a sock as neutral MOT, okay, but nothing else. Then when you declare a structure that uses the mixin, well, the operations are exported for the first time. ID exists here, but doesn't exist here. Sorry, doesn't exist here. Okay. Here it exists in the form of, I'm not even sure I can find it, but if I say as neutral.
Yes, as neutral.id should work.
Or exports ID, I don't ever remember. Yeah, okay, that one worked. But it's not even with the right type. So if you see here, it takes the parameter of the monoid structure, let's say, the carrier of the monoid structure, the class of the monoid structure. Okay, while the one we give you when you declare the structure,
not the class, the mixin.
Yeah, okay, yeah, so right, sorry, the mixin. While the one we give you here is different because it's about the structure of monoid. So, well, I don't know, maybe it was too much. And blah, blah, blah. So the two instances work. And now the last thing to work is, to test is if I can use my new factory to build an instance of the monoid. For example, I want to build an instance this time for multiplication and 1. And well, I have to adapt a bit this theorem. And if I put verbose, I should see something. This is also how it works internally. Okay, there is no parameter, so it doesn't section, but then it discovers that it can build a magma for mul, and then it discovers that it can build a monoid for mul, and then it declares these two canonical instances. So now this inference works. It finds the second one. So yeah, that's what I wanted to do as a tour of the code. And And I open up a request, and I hope you will help us finish it. And that's all I wanted to show you. You are welcome to ask more questions or not. So how scary was it from 1 to 10?
9.5.
How much did you say?
I said 9.5. No. Nah.
Pierre-Yves says 12.
That's an index out of bounds. I mean, then I'm not used to lambda prologue LP, cork LP, or anything. So,
Well, clearly, I don't expect everybody to jump on board and start hacking the code, but at least it should be roughly clear how it is organized. And then I hope the ones that want to contribute to it learned a couple of tricks on how you can find out where the problems are. And of course, there is a Zulip chat where you can ask for the gory details.
Let's say the debugging facilities seem to be somewhat minimalistic.
Yeah, they are very, I would say, absent. There is a there is a tracing facility.
Yeah.
Without
I
the
was going-
browser,
That's what?
it's a bit hard to read. I mean, it prints a trace, a very detailed trace of everything that goes on, so you can really find out all the details. But I don't have yet a graphical browser that lets you jump and quickly jump from find what you need in the trace and jump backward to see how you got there.
Yeah, I mean,
It's
the
planned, but
things
it's not
that
there.
you would like to, it's like, it's so you get an error, and it just points you to the to the place where the errors occur. Or,
Yeah, something like
or
this.
you mean you have no runtime debugging at all, right?
There is no interactive debugging.
Yeah, that's so you cannot just.
Well, that's
Yeah, that's
time will tell.
What?
Hopefully, there will be not an interactive one, but at least a decent browser for the traces.
Yeah, I mean.
So I have a very good browser for the traces. It's called Enrico.
But I think it is severely limited in the number of traces it can browse or compute analyze per day.
So are there other questions? So Reynald is talking in the chat. He's asking what's left to do to have morphisms in MathComp, and my answer was support MathComp and clean the code that Enrico just published. And foreseeing do we foresee major problems?
I'm trying to figure out is it enough to support morphism?
What Enrico did today?
Yeah.
You mean? Yes. I mean, it passed a file with all the functionalities of HB. So there might still be bugs, and there are things to clean up, but I think it's almost enough.
It's
So
kind of
we didn't test
reassuring that this
everything in
took
there, but-
only like 2 hours.
Well,
It
I
was
cheated
mostly
in the
about
sense that the code is organized like this because we wanted to give this demo. Otherwise, it would be a single file of 3,000 lines with a bit less comments. So
no, but what I was more saying is, okay. I mean, I think this extension was to a large extent about removing a restriction that had just been enforced for no good reason, right?
particular reason. Yes.
So this is not the.
There was a good reason to enforce it. We wanted to minimize
You
the
want to
number
get
of
somewhere,
cases.
sure.
We wanted to make sure that in the cases we were targeting in the first place, everything was with really inferred. I mean, with really.
Yeah, sure. No, this is okay. Maybe this was not what I meant. Like, but for no foundational reason in that sense.
Yes, it's
So
only for pragmatic reasons.
yes,
And Renald is asking, does inheritance should work thanks to what it was already been it's so small on my screen. What was already
Yes, the
implemented
fact
for
that the
hierarchy.
carrier is a type instead of a function changes very little.
It would be a bigger change to support any coercion target because most of the time the coercions to things that are neither sort or I mean neither sort class or fun class, they are not uniform most of the time, so we would have a problem. But with explicit coercions, it could be done as well.
wait. What exactly do you mean by explicit coercions?
For example, val is a coercion that is explicit, right?
Okay. So
Because so if we want to support target classes which are random types, we may have to make some coercions explicit. I mean, not in implicit coercions.
yes, but I mean this is already. I mean, this has very little to do with HB, right?
Yes, it has nothing to do with it. I mean, it has to do with the HB just in the way that if we want to support these kind of things, we have to take into account the limitations of COC, and it would make the code slightly more complicated to circumvent these limitations.
Yes, but this is not this is something a masscom is do well. I mean, it's done manually anyways already in masscom.
Yes, sure.
So yeah, I have lost. I mean, I can't even give an order of magnitude of how many instances of val I've used.
Okay. More ratings. How do you feel about continuing the implementation of the hierarchy of morphisms for the one who are interested in this? I don't know. Renald, I think. Quentin, Pierre-Yves.
What do you mean by implementing?
Fixing the implementation of. I mean, the demo was not is not the final code, right? It's a functional code that needs to be refactored. So, is it something that you would be untested as well?
I'm okay to test it. Modifying the code, it's a bit hard to say. It's a bit poilu. No, it's a bit tough. It's a bit tough. So I'm not sure. I mean, I can try, but I'm not sure I'm the best one to try to do that. But I would be, meaning I would be very, I would be interested in testing it, yes, and then telling you what's not good, what is wrong, maybe, and what could be improved. Yes. I don't feel comfortable with modifying HB currently.
That's maybe another thing we wanted to discuss today was which other features
Yeah.
you guys believe are worth doing. So this one is half done, let's say. What else?
So there is one big feature. Sorry.
No, I just gave a pointer to a file that is written by trying to mimic pack classes for carriers with functional type. And I just wanted you to just take a quick look at it. And if you think it may go through this new version of hierarchy builder, I'm willing to test it next week.
I
Maybe.
think it should go through modulo bugs. Actually. I mean, I see no major difficulty. Maybe Enrico forgot to remove a type in one line, and you would have to remove it or to replace it by something that makes sense. But from what I see, it should go through.
Wow.
I was saying that there is one more kind of hierarchy that we must tackle at some point, and is harder to do than hierarchy of functions. It's a hierarchy of predicates, because it's much more tied to how pred type is implemented. So we might have more work to do, I think.
Yeah.
Okay.
Yeah.
So let's stop here.
Okay. So if you want to help, what we do, meaning we.
If you want to what?
To help. You can take. I can.
You can try your own stuff with the HB.
And then I ping you on the lip.
Yes.
So I pushed the code I wrote. I pushed it to a branch.
Meaning the examples? The examples?
I think I did add the example as well.
Yeah, would be great.
I opened a pull request actually. So
if I go to GitHub,
you find the code and then
I go to Matcomp. What I do? Yeah, key builder, and then there should be where I am.
I can give you the link in the chat. It's easier.
Yeah, please.
Should we release Enrico?
Sorry?
Sorry. I was wondering if we should release before trying to merge 179.
No.
Why? Oh, yes.
After. Why would you release it before?
So as of today, because as of today, we know we have tested the code about hierarchies of types quite extensively. So I would be more comfortable if we had a version that we know works 100% well. or 99% well on.
No, you mean before letting gremlins touch the code?
Well,
No comments. That's what I said.
I think if you do new features, the gremlins show up from in the code all by themselves.
It's just that right now we have a code that is functional and that is refactored thanks to a lot of effort Enrico put in. And if we merge anything like 179, it will make the code less well refactored while adding a functionality that we didn't test. So that's why I'm suggesting to release before.
It makes perfect sense.
Anyway. So the code is there, and I'm happy if Reinaldo tries it on his monads.
I plan to do it maybe next Thursday or Friday, because I cannot buy it by Friday. I think it won't be possible.
Maybe you want an expert in HB to assist. I mean, that would have started at least.
Yes, I think it would be good. I took a couple of notes. I'm sure I can do it by myself, but it will. I will be faster by an order of magnitude if you help me. If it is what you are thinking of.
Yes.
So we can plan some meeting next week by Friday. You and me.
Maybe if you make it public, it will be yet another example of porting an existing hierarchy to HB as the one you did in order, as what you did for order. It's just that you may end up on some bugs because the code was written in half an hour. So
yes.
Yeah, we have kind of a GFLA workshop in Japan in the next days, so it's not possible to do it right now. But Friday it will be okay.
well,
okay. Will one of you do you know the list of participants to this meeting? So that I give the pointer to the video to the relevant people. Can you send it to me? Or should I just guess? Oh, actually, I can probably find it from the first minutes in the video itself.
I would advise that you take from the 30th minute or something like this.
Yeah.
well, then
So I'm stopping the recording now.
goodbye.
Yeah.
Okay.
Thank you.
Bye.